Okay, hello Year 4 and welcome back. This is your friendly neighborhood math teacher, Mr. Ahmed, and we're going to be carrying on to lesson 2 from our last lesson of area and perimeter. Okay, let's get stuck right in. Before we do go on, let's just quickly mention today we're going to learn how to draw rectangles with differing perimeters. Okay, and we're going to learn what rectilinear means. I know we started this recently, you may have an idea, or you may fully know. But let's have a quick go and look a little bit deeper to what we're talking about. Okay, so for this lesson, you're going to need a nice sharp pencil, a ruler, maybe an eraser in case you make a mistake, and some paper. I've attached some dotty paper with the work, but if you don't have a printer or you prefer to use your own dotty paper or you'd rather use lined paper, then you feel free to use that. Okay, and if you do not have any of those things, pause the video and go grab them, and I'll be waiting right here. Okay, um, so let's be prepared for this lesson. Here it comes. So we should have done, after the last lesson, we had a short knowledge quiz, which I've put up for you. We'll go over the key vocabulary, we'll do the recap on what perimeter is, we'll practice how to draw some shapes with specific particular perimeters. There's a small independent task. We'll do some answers with that. And then there's a final knowledge quiz then, which I'll probably send out to you tomorrow. Okay, so key learning to draw rectangles with different perimeters, and the key vocabulary similar to last lesson. We've also got rectilinear. Okay, that's a funny old word to say, isn't it? I always find it helps if I say the word a few times out loud or in my head. And you can say it along with me because I'm going to say it out now a few times. Rectilinear. Okay, rectilinear. It's a funny old word, but say it a few more times if you want, just to practice. Okay, so after rectilinear, we've got length, we've got breadth. That's a tough word to say as well. Perimeter, we know perimeter, and we know double, centimeters and millimeters. These are our units of measure. Also, we've got meters, and we've got, different measurements. Okay, so first off, then I hear you ask, what on earth are rectilinear shapes? So have a look at the screen, and the little yellow box at the bottom will give you a definition. So rectilinear shapes are shapes which will only ever have lines that meet to make a 90-degree angle. We all know from last time and from our knowledge a 90-degree angle is also called a right angle. So let's have a look in the corner of these. See these lines? They're joining up here. Those they will join up then to make a right angle in here. Okay, so that'll be 90 degrees. That angle, if you were to measure it, it'll be 90 degrees. And similarly, all of these angles, inside and outside, they will all be at 90 degrees. Okay, there's loads of these like this, like staircases. And we've got another one in here. So there's lots of different shapes. They all look very different. They all have they all rectilinear, they all have right angles. Okay, so that's very simply what a rectilinear shape is. Now you can look around and see if you can see some in your homes or see where you might have seen them before and not realized. And that's what rectilinear means. Okay, so let's warm up our brains then. On your dotted paper that I've given to you that you printed out, or on your lined paper, whatever paper you're using a nice sharp pencil and ruler, can you make three different rectilinear shapes with a perimeter of 16 units? Now, 16 units, you may be wondering how long is a unit, and that's entirely up to you. Your centimeters, your screens, our screens are all different sizes, so we just use the word units. So there's no pressure for having centimeters or millimeters, so you can do it entirely up to you. Now, if I ask you to make one for 10 units, okay, let's erase that and let's just write 10 units. On my screen, on my size paper here, that would mean 10 of these lines, so 10 joins essentially in between. So I'll go ahead and draw 10, and you can you can see what I mean. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, oops, 8, 9, 10. Okay, so if we count them, that means I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 of these spaces in between the dots represent 10 units. So if I was to measure these with a ruler, maybe that's 1 centimeter in between each dot. Maybe there's a lot more depending on your screen size. Okay, so we've just used the word units just to help with measurements. Okay, so you go ahead, draw 3 of them, or as many as you can, with 16 units perimeter. And I'm gonna pause it. You can pause it, and we'll get back together in a minute. Okay, so here are my 3 ideas. Notice one thing. Although they all have 16 units as a perimeter, they all look very different. Okay, so that shows us that just because a shape has the same perimeter as another shape doesn't mean it'll be the same shape. So if you don't trust me, let's all count. I'm going to count the first one out loud with you, and if you want to count any more after, you feel free to test me. And if I've got any wrong, please let me know. Okay, so we need 16 units. Okay, 16 units. I'll just write a U. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units. Check. So that's definitely 16 units. Okay, now if you want to count the other 2, just to make sure I'm correct, you feel free to do that. And I hope you've checked yours as well. Make sure they haven't. You've got 16 units. If you didn't, then maybe you can adjust them. Okay, so we've got an activity, short activity coming up. Your first task on your dotted paper, on your squared paper, or on your lined paper, if that's what you have. Let's draw. I'm going to give you the description of 4 shapes with different perimeters, and you're going to draw them out. Okay, so the first one, A, let's give you a clue here, 4 equal sides of 5 units. So remember, units can be anything that you want, so long as there's 5 of them. On my paper here, we've got a very small space in between, so mine would be 5 of these. Yours might be larger, so just make sure they're 5. Okay, so any shape with 4 equal sides we know is a square, exactly. So there's a clue for you there. And then 2 sides of 11 units on B, 2 sides of 11 units, and 2 sides of 4 units. Basically, there's 2 equal sides, 2 opposite sides are equal, and the other 2 opposite sides are also equal. Therefore, that shape is an oblong rectangle. I'll leave those little clues with you in your mind. You go ahead, draw these 4, and we'll get back together and I'll go through some of my opinions with you. Okay? So here we go then. How did you get on? Let's work out some of the answers together. So A was 4 equal sides of 5 units. Okay, so if you are a little bit unsure, you can always draw them out. Okay, I always find it helps me a lot if I can draw them. So let me draw a nice thin line here. So 4 equal sides of 5 units. So we need 4 lots of 5 units. So basically it's 4 times 5. Okay, so I'm sure you all know the answer to that. So that's, if you struggle with just the numbers here, if you're anything like me, you'd like to draw them out. So I've drawn 4 equal sides. It's not quite equal. My drawing is horrendous, but when we put our numbers in, 5 units, all 5 units, don't forget I'm going to write units in here. We always need some measurements. Okay, I'm going to leave that as a U because you know what I mean. 5 plus 5 plus 5 plus 5, we could see that. 5 times 4 again is 5, 10, 15, 20. So 20 units. That's that one done. Okay, so B, 2 sides of 11 units and 2 sides of 4 units. Now I find it easier to draw them and so I can see the numbers. If you don't, feel free to just put the numbers in. So we know two sides are 11 units. So the longer side, you've got the numbers 11 and 4. So the longer side will obviously be 11, and the shorter side will be 4. And the opposite sides will be equal. So therefore, our 11s, let me make them look like 1s, so we're not confused over that. Okay, so we've got two 4s and two 11s. Remember our formula for triangles? We've got 11 plus 4 in our brackets times 2, and our brackets means that we do that bit first correct. So 11 plus 4, so what's 11 plus 4? 11, 11, 12, 13, 14, 15, and then 15 then times 2, we all know is 30, 30 units. So we've doubled 15 essentially by times it by 2. And if you're not sure, you can just count them all up individually if you want, but that's the long way, and we're trying to do things quicker. Okay, so see then, two sides, we got two sides of 10 units and two sides of 5 units. So I'm going to draw it, use a different color this time. Let's go for a blue, come on in. Okay, so there's my rectangle. We've got two sides of 10 and two sides of 5. So the longer side will be 10, correct? And the shorter side will be 5. I'm going to pop a U in here just so you know it's units, okay? So I've got something in. So we know there's two sides of 10. The opposite side will always be the same. So 10 units will be there. And the opposite of 5 again will be 5. So let's use our super duper math and pop our numbers in. Open our brackets. Oh, that's not correct, is it? So we've got 10 plus 5. Close our brackets in. And we know that we've got to do that 2 times. So 10 plus 5, 15, good. 15 times 2, where have I heard that before? Equals 30 units. We'll come back to that in a minute. So let's go to D. D, 4 equal sides of 8 units. So if it's 4 equal sides, we know that all sides in a square are equal. Good. So we've got 8, 8, 8, and 8, all units. Okay, so basically 4, we need 4, 8 times. And what's 4 times 8? We all know our times tables. It's 32 units. Okay, excellent. Okay, hope you got these. Let's go back though. Have a look at this yellow box. Which two shapes had the same perimeter? And if you answered B and C, you would be correct. So the shapes will be different. They'll look different, but their perimeters are both 30 units if you use centimeters or whatever you're using. So they had exactly the same perimeters, but slightly different looking shapes. Bear that in mind as well for the future. Okay, so how can I draw a rectangle with a perimeter of 24 centimeters? So the simplest thing here to do is we know that if I'm looking at this here, I know that the whole thing is 24 centimeters. The perimeter around all of the edge here is 24 centimeters. So if I was to half this triangle along the middle, on each side you have one long side, and one slightly shorter side. The length is slightly longer than the breadth. Okay, and on the other side you also have the same. One slightly longer side and one shorter side. So that's half of the rectangle. So if half of 24 is 12, is it fair to say that these two sides added together equal 12 centimeters somehow? And then if they're the same here, somehow there's two numbers on this side which also add up to give us 12 centimeters. Yeah, I hope you can see that. So whatever these two numbers are, they will add up to 12, and whatever these two numbers on this side, they will also add up to 12. Okay, so what are these numbers? Are they just one set of numbers on each side? Or can there be more than one? Can it be lots? I leave that for you to think about, but you're sure you'll get an answer soon. What if we have a look? So we'll have a look at this part now here. Okay, we're going to try and go through one way of working this out. So like I said before, we've got one long side and one slightly shorter side on each side, and that represents these two here. So these two need to add together to make 12 centimeters. So let's think of two numbers that add together to make 12. And probably the simplest one, say, is 10 and a 12. 10 and a 2, sorry. So our longer side should probably be 10. And oops, let me get a pencil. Pen. Our longer side will be 10, and our shorter side will be 2 centimeters. Let's use centimeters. Okay, so we know this half will be 12. Therefore, the opposite lengths will be equal. So if this length here is 10, this length will also have to be 10. But if the breadth here is 2 centimeters, this then will also have to be 2. Because remember, opposite sides are always equal in a rectangle. So therefore, we've got 12 on each side. Then we've worked out that each length and breadth will have two numbers which add together to make 12. And then once we've doubled 12, we've got 24, which is our overall perimeter from the question. Okay, so that's one way. So ask yourself this question. Are there any more numbers which you can add together to make, first of all, to make 12, and then double that number then to make 24? Is it just 10 and 2? Can it be any other combination? Can it be 1 and 11? That works. That works. Okay, so I've drawn a little table on the next page. You can copy this table if you like, or you can just write notes however you want. And I've already done something for you already. So let's fill this in, okay? So on what I've done on the last page, we've got a length of 10 and a breadth of 2. And we know that all opposite sides in an oblong rectangle are equal. So the length on one side is 10. The length on the other side has to also be correct, 10. 10 what though? We are using centimeters, aren't we? Let's not forget our centimeters. So if the breadth here is 2 centimeters, what does the breadth have to be on that side? Correct again. It has to be 2 centimeters. So what does that give us a total of? So we know 10 plus 2 is 12, and we're doubling that again to make 24. Okay, so we can either do our rectangle formula, 10 plus 2 times 2. What's another way we can do this? Using our counting with tens, because tens are easy to count, aren't they? Yeah, we've got 10 plus 10, which is 20. Oops, we've got 10 plus 10, which is 20. 2 plus 2, which is 4. So we just partitioned it a little bit. So we know 20 plus 4 is 24. So I'll leave that to you. Can you think of another few combinations, all add up to make 24 centimeters? Okay, I'll be back with you in a minute. Okay, hi guys. I hope you guys had some luck. Can you think of another few combinations to give us 12? And I'm sure you guys have done many different combinations. So I'm going to go ahead and just do a few. It's quite difficult to check our answers because for this one, there's no 3 correct answers. There's many different ones. So as long as they add up to 24, then you can give yourself a mark. So we know the first one adds up to 24. We've checked that. Okay, let's go for a second one. So let's think of two numbers which add together to make 12 on one side. I'm going to go for 8 centimeters on one side and 4 centimeters on the other side. So I'm going to draw that one out as well. So we've got 4 and 8 centimeters. So if we've got 8 length on one side, the opposite length has to also be 8. Perfect. And if I've got 4 on this side, the opposite to that also has to be 4. So therefore, we have 8 centimeters here and also 4 centimeters here. So let's add these together. We've got 8 plus 4, oops, times 2. So 8 plus 4 we know is 12, times 2, 24. Give myself a mark for that. Oops, there you go. Okay. Or we could be really, really sneaky. Well, not sneaky, but we can be simple and say 11 and 1. They also make 12. So if I were 11 centimeters on one side, what's the length going to be on the other side? Also 11, correct. If I could write 11 properly, that would help. Okay, 11 centimeters on one side. Therefore, our breadth on one side is 11, and our breadth on the other side will also have to be 1. I said 11, I mean 1. Okay, 1 centimeter. Does this add up? So you can plug it into our formula. 11 plus 1 is 12 times 2, 24. Okay, so give ourselves a check if they add up to 24. We can write centimeters, centimeters. Don't forget our units, very important. Okay, and our final activity for today, using a ruler, I'm going to write down um, 3 different measurements, 3 different perimeters, and you are going to try and draw these yourselves. Okay, so the first one I'm going to ask you to do is something with 20 units. Okay, so that's number, that's A for you. And then B, I'm going to ask you to draw one with 10 units. Nice and easy. Okay, and C, I want you to pay special attention to C because what I'm going to ask you to do is draw one with 9 units. Okay, let's see how you get on with C because I'd like to know what you think of C. Now, if you could notice something different between the 3 numbers, 20 is an odd number, even number, sorry. 10 is also an odd or even. It's even. What's 9? 9 is an odd number. Is that important here? Can you make a perimeter with an odd number? And if that did not work, can you think of another number which is odd and try and make a perimeter, make a shape with a perimeter of that odd number, whether it's 9 or 7 or 13. Think about that, okay? And like I said, this is a final activity, so just bear some questions in mind. So we'll be coming back to these. Like I said, tomorrow I'll be posting a knowledge quiz so that we can assess and we know then who's done these lessons and who hasn't done the lessons based on your answers from tomorrow. Okay, so some questions for you to keep in your mind and to think about. Do shapes with the same perimeter always look the same? And can you make a shape with a perimeter that is an odd number, or are all perimeters even? And think about what the formula is for calculating these perimeters. Okay, so we've been using them for the last 2 lessons now. They should be firmly in your mind, and so you should do them with a click of a finger. Okay, that's your final slide. And on that, we'll conclude. If you have any questions, any comments, feel free to ask me, ask your teachers. And I hope you've enjoyed this as half as much as I've enjoyed putting it together for you. And I hope this clears things up. And I will catch you for lesson 3 in a few days' time.